Welcome to Unit 1.3 of AP Chemistry. We're going to learn an elemental composition of pure substances. So, the law of definite proportions. So, this is Joseph Proust's law. What he's saying that any pure sample of a compound will have the same ratio regardless of source or sample. So, I can get some water from my tap in my house, and I can get some water from the river. They will have two atoms of hydrogen and one atom of oxygen, regardless, and it will always be 11% hydrogen, 89% oxygen by weight. It does not matter where I get that, how much I get. I could get a milliliter, I could get 100 milliliters. They will be exactly, um, they will have the same proportions. Okay? My image didn't load here, but this is how you calculate percent mass. So I think there's an example problem like H2O. It wants us to find the percent mass of H2O. So I'm just gonna do that real quick for us. Um, so the percent mass of H2O. So remember, H2O is. Let me write it up here. H2O. There's two hydrogens, one oxygen. Hydrogens weigh approximately, or 1.08. That actually might be the exact number. Oxygen weighs 16. Okay, so now if I do this, that be times 2, this be times 1. And the reason I'm multiplying by 2 is because there's two hydrogens, and there's only one oxygen. So if we add this up, this is like around 2, and this is around 16. So if my memory is correct, the weight of hydrogen or water is around 18.016. Okay, so the total weight of water is 18.1016. Now let's say I want to figure out how much of that water weight is just hydrogen. Okay, how much of this is just hydrogen? What I would do, I would say, okay, hydrogen is approximately 2.016. So I would just do 2.016 over 18.016, and I'm gonna put in my little handy dandy calc right here. See what numbers we're dealing with. 2.016 divided by 18.016. You would get approximately 11.19%. Okay? Now, I'll do the same thing with uh, oxygen right here. So, what we do right here, you say, okay, oxygen weighs 16. My whole thing weighed around 18. So, now I will just do the same division. So, this thing's going to weigh approximately 89%. Okay, simple. Easy peasy. That is how you find the percent mass. Uh, that is just saying the slide. Okay, empirical versus molecular. Empirical formula is going to be the simplest formula you'll get. So C6H12O6 is the molecular formula of glucose. It's the actual number of atoms in that molecule. Um, the empirical will just be you'll just kind of figure out like the greatest common denominator. So like all of these have a factor of 6 that you can pull out, so it becomes C2O. It would actually become C2O. That would be the empirical. So like I know the slide looks kind of. Let me just go right here. So so the molecular looked like C6H12O6. The empirical, on the other hand, will look something like you can pull a 6 out on all of these. Okay, so it'd become CH2O. Because 6 divided by 6 is 1, 6 divided by 6 is 1, 6 divided by 6 is the 2 right there. Cool beans. Um, Next up, how do you get to the empirical formula? We're gonna have to. How do you get to the empirical formula? There's a whole process, and so you could watch this: percent to mass, mass to mole, divided by smallest, multiplied to whole. That is a process to remember. But I'm gonna do a challenge here and then get you there. So we have this thing right here that's telling us that a compound is 40. Like, I know it's hard to tell, but I'm gonna write it down here so we kind of understand. It's telling us that it is 40% carbon, 40% carbon, 6.7% hydrogen, and 53.3% oxygen. 6.71% hydrogen and 53.3% oxygen. Cool beans. And find the empirical formula. Because remember, the empirical formula is the smallest one. We're not trying to get to the molecular, we're just trying to get to the empirical. So when you think about this, 40%, you always convert these to grams. Any number you get here, you'll convert to grams. And the reason you can do that, say I have 100 grams of something. If 40% of that is carbon, that means 40 grams of that is carbon. So this will be written as 40. Let me erase all this stuff so it doesn't get in the way of what we're about to do right here. That part I think we're far away from. So 40% carbon will turn to 40 grams of carbon. This will turn to 6.71 grams of hydrogen. And this will turn into 53.3 grams of oxygen. Cool. Now, what do you do next? So, remember the whole thing. You had like grams, moles, particles, something like that. You always go to the moles. Like, moles always the thing in the middle. So you always, anytime you see something you don't know what to do, just go to moles first. So we're gonna have to go to moles on all of these. So, and remember, I think white's kind of hard to like look here, like pink. I might have to change this purple background genuinely. Um, so grams. Remember, we want to cancel grams. So gram must go on the bottom. On all of these, we want to cancel the grams. And we want 1 mole of this. We want 1 mole of this. 1 mole of this. 1 mole of this. So 1 mole of carbon is around 12.01 grams. 1 mole of hydrogen is around 1.08 grams, and 1 mole of oxygen is around 16. So now I'm gonna figure out how I'm gonna get my moles here. So um, I'll just do 40 divided by 12.01, and that'd give me around 3.33. And you can fact check that. If you do this number times this number, you should end up with this number. Okay? If you don't, then you did something wrong. 6.71 about 1.008 will get you 6.65 moles. And right here we'll get 53.3 divided by 16. We'll get you around 3.331. Okay. This is 3.330. This is 3.321. Okay. The reason I had to, I'll tell you why. Because the next step here, let's see how good this color is. It's actually pretty good. The next step is you have to divide by the smallest number. The reason I added another decimal here is because they were literally identical. So this 0 right there. There's a 0 right here. So now what we're going to do, we're going to divide by the smallest. So we're going to divide by 3.330 on all of them. Of course, this divided by this will get you 1. This divided by 3.330 will get you, I'll have to go on the calculator. And 6.65 divided by 3.330 will get you around 1.99, so pretty close to 2. And this divided by 3.330 will probably get you 1. Like, more likely than, yeah. This is really close to 1. So now, what does this mean? That means our formula, our empirical formula, is going to have the numbers CH2O. That should be the answer that I got on the slides. CH2O. See, first thing you did is you figured out the percent mass. You did the mole conversion. You got all these mole values, and then you divided by the smallest. So you did this. You got 1, 1, 2, 1, and then you get that. Cool. The multiplier. So where does the whole multiplier come from? If you want to find the molecular formula, so this is, I'm pretty sure this is glucose, yeah. If you wanted to find the molecular formula, what we found was the empirical formula. Okay, we found the empirical formula. This is not the molecular formula for glucose. To get the molecular formula from this, what you have to do, is you have to first, like, say I have the molecular formula. Like, this is the molecular formula, right? C6H12O6, pretty famous. What I have to do is I have to know the atomic weight of this whole thing, which is 197, I believe. 197, I believe. Or no, I think it's just 97. Nope, it is 12 times 6. Sorry, I should have these numbers down. Plus 12 plus 16 times 6. It's saying it's 180. C6H12O6 is 180. Why am I like, what is the... Yeah. So it's 180. And so what is the weight of this thing? So we're going for the atomic weight of this thing, which is just going to be 12 plus 2 plus 16. So 18. So it's like 30. Okay, this is like 30. So now you have to figure out what's the ratio of this thing to this thing. Remember, that's what the slide told us to do as well. The slide told us to go from molecular divided by empirical. The weight of the molecular, so 180 divided by the weight of the molecular, 30, will get you a multiplier of 6. And that means all of these things need to get multiplied by 6. So you would do C1 times 6, C6, 2 times 6, H12, 1 times 6, O6, and guess what? Now you're back at the same level that you wanted. Okay? Okay? This I'm not going to worry about. There's some challenge problems. I'm going to do one of these. So... Okay, I'm going to do number 2. And an organic molecule has an empirical formula CH. If its molar mass is determined to be 78.1% or 71. Okay, what is its molecular formula? So we have CH. So it's telling us, okay, it's telling me that we have something CH, and the molecular formula has a mass of, I think, 78. I could be wrong. I need to go back and check. I'm pretty sure it's a 78. So the molecular has a mass of 78. Okay? What is the molecular formula? The reason I know the molecular has a mass 78 is because CH It's just 12 plus 1. So this thing right here has a weight of 13. So that's how I knew the 78 belonged to the molecular one, because this thing is not heavy enough to be 78. Okay, but now remember I told you we need the multiplier. This is the empirical already. This thing right here is the empirical because it's the smallest number. We want to get to the molecular, so that means we need to do the mass of the molecular divided by mass of empirical, and that will get us the multiplier. So this will just be equal to 78 divided by 13. Let me do a different color there. 78 divided by 13, which would get you 78 divided by 13 would get you 6. So you would multiply these by 6. So you would do C6H6. That's the formula. C6H6. C6H6. Number 2. C6H6. We did it, boys. If you have any questions, let me know in the comments, and I'll try to get to them. Have a nice day.